Bonjour, hello, it's great to be back. And I must, first of all, I must apologize for a problem that I have. I prepared a talk, and then I heard one more person after another say that I was going to talk about the semantic web. Well, you know, I hadn't intended to do that. I just tended to say a little bit of motherhood and apple pie about the role of science in society, which we know, in information society, which we know is very important, and not really go into the semantic web because I thought it would take too many slides. But I have been put under some pressure to put in the semantic web bit. So I am resolving that I'm not now responsible for your timetable. This will overrun a little bit. But there you go. So I'm going to start with some of the original talk, and there will be a time at which we'll switch across. And if you're watching this remotely, then it's obviously a good idea to watch the slides on your own browser. And in this first slide, in green, illegibly, if you're perhaps on your monitor, but there is the URL of the slide, so you can follow along yourself and you don't have to rely on the video for the slides. So what's the web? It's fundamentally, it's a decentralized thing, and practically when we really use it, it becomes a fractal thing. And that's what I'm going to discuss just a little bit. So this initial talk was about the invention of the web, its genesis here at CERN. Here at CERN without the red carpet and with blackboards. And I was very tempted to go and get a piece of chalk and sort of draw the curtains aside and go use a piece of chalk just to get back to basics. But I'll resist the temptation. So going back then, okay, this is the difficult thing now. It used to be difficult to explain what the web would be like. Now it's difficult to explain why it was difficult, because it's so obvious to everybody. But back in the 1980s, at CERN, it was an exciting place to be. Lots and lots of information systems on different computers, on different networks, all incompatible. So the idea was that one should be able to communicate by sharing information. Now, there are different models of communication. One of the models of communication is that I say a whole lot of things. I send you a lot of messages. And then later on, after you've digested them, and maybe understood them and maybe not, you send me a lot of messages back. A lot of communication works like that. But there's another way of looking at it, and that is that we decide to build something together. And we get out a big sheet of paper, and we sit down next to it, and we fight over who has the red pen. And then we draw, and we erase, and we use that blackboard. And that's interesting because as we go through that process, we are building something together. We end up building a document which has got common terms that we understand. So the idea of the web was to be able to do that, but across the internet. And hopefully, because we're using computers, to be able to not only have the finished product, but also track how we got there. So I called that interactivity at the time, but since then people said that forms on websites were interactive, so I then called it intercreativity. So the need was for an intercreative system, and the challenge then was that at CERN there was a lot of data. There is a lot of data. There was a lot of information about how things worked. It was not practically available. It was on a computer, on a network, but not on your computer, not on your network. And if you could get hold of it, even on a floppy disk, and put it on your machine, it would be in an incompatible format. So there was a lot of heterogeneity. Okay, now heterogeneity is a good thing. Diversity is a good thing. To run a place like CERN, you don't want to just tell everybody to buy the same computer system. You don't want to just tell them to all use the same mail reading software, especially if it's the sort that distributes viruses. So it's good to have a variety of types of machine, of sorts of operating system in a large organization, especially when it's composed of people coming from lots of different home institutes. And because people at CERN, of course, come from different home institutes, they come with instructions and customs from those home institutes. And they don't necessarily want to change them in response to some hierarchical order at CERN. So CERN was an interesting place to be. It was advanced. It was it was somewhere where in 1989 most people had some sort of a workstation on their desk, which was unusual then, and a place where the internet, the network connectivity had just arrived. Well, the network connectivity had been there for a while, but it was just becoming politically all right to talk about the internet instead of ISO European protocols. So in a way, CERN was interesting as a microcosm of the world, a sort of substrate. And the solutions, of course, you know, it's the web. It's taking the idea of hypertext, taking the internet, which I did not invent. That was 20 years beforehand, okay? I just did the www thing. And how did I do the www? I just took all the information systems out there and looked for and generalized. What is the abstract information system which would be sufficiently general, sufficiently flexible, such that each of those systems could be a part of it? So that meant I wanted every system out there to be a part of the World Wide Web. And to ask something that big of everybody, I knew that I could not tell them all to write an HTML, or tell them all to store it on the mainframe, or tell them all to store it on a Mac or a PC. I had to let people store it however they liked. I had to be as flexible as possible. So hence this design constraint on the web, which is still with us and still very important, of minimal constraint. The web architecture constrains as little as possible. It shouldn't constrain how you think. It shouldn't tell you how to organize your data. It shouldn't tell you what software to use. It should allow you to invent new applications within the web whenever you feel like it. So very quickly, here are some milestones. I wrote a memo in 1989 suggesting the idea. Really, remember, this is not a software tools organization. It's primarily physics labs. So very properly, it has got all sorts of traps set up to stop people who are supposed to be doing physics having a great time programming just whatever they like. And this is very necessary because programming environment is extremely fun for anybody who's got any creativity and a computer, and certainly that applies to almost all the people at CERN. So everybody would be off designing all kinds of things unless you weren't careful that you made sure you bought off-the-shelf everything. So the very proper response to the web idea was, if it's a good idea, you should be able to get it shrink-wrapped. Go buy it off the shelf. If it's not available off the shelf, then it must be a stupid idea. So the memo didn't get very much response. But in 1990, my boss at the time, Mike Stendhal, he suggested that I get a Next computer. Those are the black computers, which are on the outside were sort of square and black, but on the inside are very much like what an OS X Mac looks like at the moment. And he suggested that we play around with this new type of computer. At the same time, why not use do some sort of experimental project just to test it out? Why not do that hypertext thing? So I started programming that in the fall of 1990, and by Christmas had I think the date on the first World Wide Web program when I actually released was the 25th of December. I wasn't working on the 25th of December, but I could remember the date.